Hey guys, this is Mrs. Tran-Bloom. We are going to pick up where we left off from the previous notes, okay? Notice how this page, it says we're starting with example C, and we're going to go to D, and we're going to go straight to example 2. Well, let's recall example 1 direction, okay? Remember how we couldn't find where the direction was, so I kind of spelled it up here. It says example 1, solve for the triangles. So that's what we're going to do here for example C. Okay, we're going to solve for this particular triangle. This particular triangle, it didn't give you a picture, but that doesn't mean you can't draw one out. So let's draw it out. It says, hey, B is 4, that means it's 4 units. Big B is 10, and there's a bubble, so that's 10 degrees. Find A, C, little C, and big angle A. Assume C is the right angle. Okay, so here you go. Let's draw this out. So go ahead and draw a right triangle. It says C is a right angle, so there's your C. That means opposite that, it's little c. Now A and B can be anywhere it wants to be. So here's A and here's B. You can put A here and B there. Now B it gives you as a 10 degrees. So here is 10 degrees. And remember, my drawing is never to scale, so you just have to go with it. Opposite of big B is always little b. Okay? And little b is 4 units. So little b equals 4 units. A, it's unknown, and little a is also unknown. Okay, so right now we're gonna say, hey, find little a, little c, and angle A. So here we go. Angle A equals, we'll fill it out. Little a equals, and little c equals. We'll box that up. We're gonna do the work over here, and once we're done, we'll fill that in. All right, so let's talk about what we know and what we don't know. We know angle B. We know opposite of that, which is 4 units. So that's opposite. Then if you're looking for adjacent, okay, so you can find adjacent first, which is A. So let's find that. We can use tangent. Okay? So tangent of angle B equals opposite over adjacent. Okay? B is 10 degrees, so we're going to go tangent of 10 degrees. Put your bubble in. Opposite of that is 4 units. Adjacent of that is unknown. We're going to call it leg A. From here, we are going to cross multiply. Put that over 1. Okay, and then we're going to go, hey, cross multiply this, cross multiply that. So if I cross multiply, A times tangent of 10 degrees equals 4 units, because 4 times 1 is 4. We are going to divide both sides by tangent of 10 units. I'm sorry, not 10 units, 10 degrees. So tangent of 10 degrees. That will cancel. I'm going to end up with A equals. Now at this point, you're going to use your calculator. Okay, hit on, clear out what you had before, hit mode, double check to see, hey, should I be in degrees or should I be in radians? So what do you think? Should we be in degree or radian? Hopefully you're telling me it should be in degrees, which I already have. So we're totally okay. So I'm just going to punch in 4 divided by tangent of 10 degrees. 4 divided by tangent of 10 degrees equals about 22.69 degrees. Okay? I'm sorry, not degrees, units. So A equals 22.69 units. And that's why it's really important for us to write the unit of measurement. If it's an angle, we need to put degrees or radian. If it's a side measurement or hypotenuse, then you just need to put units if it's not given to us at the beginning. So that's my A. Fill that in, 22.69 U. Okay. We can also find angle A very easily. Okay, angle A, that's angle A equals 180 degrees. Take away, we know this is 90, so take away 90 degrees and take away this measurement, which is 10 degrees. Let's kind of organize myself here. So angle A comes out to be 180 minus 90, which is 90, minus 10, which is 80 degrees. Okay. Angle A is 80 degrees. Now the only thing I need to find is the hypotenuse. And technically you can use Pythagoras theorem, but the reason I said don't do it is because if you use Pythagorean theorem, this is a rounded, an estimated amount. Okay, so if you're going to use it and find hypotenuse, then it's going to be more rounded or further away from the exact. So what I would like for you to do is always use the exact measurements. For example, 80 degrees is exact. 10 degrees is exact, 4 units is exact. So always use the exact measurement to find your missing parts, all right? So because I have 10 and I have the opposite, which is 4, and I'm looking for the hypotenuse, that's opposite and hypotenuse. What will give me, what trig function should I use if I have opposite over hypotenuse? Hypotenuse. What should I use? Sine, cosine, or tangent? Hopefully you're saying sine. Okay, we're going to use sine of b equals opposite over hypotenuse. Sine of b, so b is 10 degrees, so sine of 10 degrees equals opposite of that is 4 units over hypotenuse is unknown. So from here, we're going to make it over 1. Okay, we're going to cross multiply. So when I cross multiply, c times sine of 10 degrees equals 4. We're going to divide both sides by sine of 10 degrees. If we divide both sides by 10 degrees, we're going to cross those out. So c equals about, you have to use a calculator at this point. Okay, we're going to punch in 4 divided by sine 10 degrees, close parentheses, equals 23.04. So 23.04 units. This is not a degree, so we're going to use U. So 23.04 U. Okay, so now let's kind of quickly check to see if our answers are somewhat right. So C, which is the right angle, is 90 degrees. A, we found that was 80 degrees. Well, little a is slightly smaller than little c, and that makes sense because opposite of the largest angle should always have the largest measurement. Since c is 90, which is the largest, it should have the longest measurement, which is the hypotenuse. And b, which is 10 degrees, it has 4. Well, 10 degrees is a lot smaller than 80 degrees, so therefore the measurement of that should be a lot less. So right now things looks like it's in order. Opposite of the largest angle, which is C, should have the largest measurement. Opposite of the smallest angle should have the smallest measurement. Okay. Okay. So with that said, I'm just going to have you do D on your own, but also I'll help you guys set it up. So first it said, hey, if A is 3 units and B is 2 units, find little c, which is now the hypotenuse, angle A and angle C. I'm sorry, angle B. So let's draw it out. When in doubt, sketch it out. Okay, so C, we're going to assume that's the hypotenuse again. So opposite of C is little c, which is currently the both unknown. We're going to put A here and we're going to put B here. Okay. We don't know what big A and big B are, but we do know little a and little b. So little a is 3 units and little b is 2 units. Okay, opposite of big A is little a. Now, if you look at this, we know that little a is 3, so I know angle A should be bigger than angle B. Okay, that's all I know. So we're going to write over here what we're supposed to be looking for. We're looking for angle A, we're looking for angle B, and we're looking for hypotenuse, which is C. Okay, we'll box that up. So to help you set this up, we know that these two, so let's pick an angle first. Let's just say we're going to go in alphabetic order. We're going to go find angle A first. So let's say that we have opposite and we have adjacent. Which trig function can we use? You have opposite of A and adjacent of A. Which trig function should we use? Hopefully you're using tangent. Okay, so tangent of angle A equals opposite over adjacent. Well, I know A is something that currently we need to find, so there's nothing we can do with A at this moment. But I know opposite of that is 3 degrees, and adjacent of that is, I'm sorry, not degree, 3 units, and adjacent of that is 2 units. Then from here, just like what we've done prior, we're going to cross multiply. Okay. So currently we have 2 times tangent of angle A equals 3 times 1, which is 3. And we're going to divide both sides by 2. Those two will cancel each other out. Then now we have tangent of A equals 3 over 2. Okay. Well, just like earlier, to get rid of tangent, we're going to take the inverse. Okay, so we're going to go in and take inverse of tangent. So tangent inverse. Okay, so tangent inverse of tangent A equals tangent inverse, what you do to the left, we are going to do the same to the right, of 3 over 2. Anytime you're going to look for an angle, you most likely need to take the inverse. Tangent and tangent inverse, those two will cancel each other out. So now angle A equals, you have to use a calculator, okay? So your tangent inverse button is second tangent. So second tangent, I'm going to punch in 3 over 2 or 1.5. So because A is an angle, so we're going to say that A, it's about 56.31 bubble, which is degrees, right? 56.31 degrees. Now that we have an angle A, we can easily find angle B. Angle B equals 180, take away 90, okay? Because a triangle is 180 degrees, take away the right triangle, and take away A, which is 56.31 degrees. So that gives me 180 minus 90 minus 56.31, 33.69 degrees. 33.69 degrees. And if you've noticed the pattern that you can pretty much just take 90 degrees and subtract one of the non-right angles to get the other one. You don't even have to use 180. Okay, but just to kind of show you the point that the whole triangle has a total of 180 degrees. So we know B is, we know what A is, so my last piece is C. So this is the part that I'm going to ask you to do it on your own, okay? So on your own, find hypotenuse C. Okay? So go ahead and pause right now. Try to find C on your own. So the next time I check your notes, that should be all done. And I need to see your work as well. Okay? There's no way that you can do this in your head. I don't care how smart we are. When it comes to trig and calculators involved, I need to see some work. All right? Alright, so now that you're hitting pause or you're done with your hypotenuse, let's go to example dos. Let's zoom in a little bit more. Alright, so example 2, here we go. A straight trail leads from Alpine Hotel, which is at an elevation of 8,000 feet, to a scenic overlook of the scenic overlook has an elevation of 11,100 feet. The length of the trail, okay, so this length right here, it's 14,100 feet. I'm sorry, I can't really walk on the underneath the ground. So the length of the trail, my bad, is this inclination right here. This incline right here of 14,100 feet. What is the inclination or the grade of the trail? That is, what is the angle B in figure 4? So they already gave you this picture, which is awesome. And angle B is this angle right here, this angle. So it's kind of giving you everything you need to know. So angle B, I have opposite, okay, and I have this trail, which is at 14,100 feet. Opposite and hypotenuse. And the reason I know this is hypotenuse is because it's the opposite of the right angle. So what we're going to do, we know that this is 3,000 feet, right? The overlook elevation is 11,100 feet. So, but we don't really, so the hotel is already at 8,000 feet above sea level, and this is 11,100 feet above sea level. So the difference, okay, is 3,100 feet. It didn't give it to you in here, but you can figure that out. Okay, the difference is 11,100 feet subtract 8,000 feet, so gives me this right here is 3,100 feet. Okay, so that's how they found this measurement here. So I have opposite and I have hypotenuse, so most likely Hopefully by now you can tell me what trig function we should use. I have opposite, which is 3,100 feet. I have the hypotenuse. I'm hoping that you're going to say sine, right? Sine of angle B. Okay. So sine of angle B, we don't know what B is, so we're going to keep B as B. But I know opposite is 3,100 feet over 14,100 feet equals sine of B. We are going to make sine of B into a fraction, so we're going to cross multiply. Cross multiply, cross multiply. So this is going to give me sine B times 14,100 feet, a 14,100 feet sine of B. Always write the constant in the front equals to 3,100 times 1 is 3,100. I'm going to divide both sides by 14,100. 14,100, 14,100. So cross that out. We now have sine of angle B equals, looks like I can pretty much cancel those zeros, right? So 31 over 141. I'm looking for angle B. Okay, so it says here, what is the angle B in this particular word problem? So angle B, to get rid of sine, we're going to take the inverse. So sine inverse to both sides equals sine inverse to both sides. What you do to the left, do to the right. So I'm going to rewrite both original pieces in. 31 over 141. Sine inverse and sine, those two will kind of cancel each other out. So now we have B, angle B equals, I have to use my calculator. Alright, here we go. So turn it on, clear out what I had before, hit second, sine, prompts sine inverse. Then I just have to do 31 divided by 141 because the zeros cancel out earlier. So B is about 12.70 degrees. And the reason I know it's the right degrees is because B is an angle. So the inclination of the trail, the incline of the trail, oops, can you see that? My bad. Is about, because we rounded, so we're going to use this, about 12.70 degrees. Okay. Alright, and that concludes our notes for the day.